We talk a lot about hydrogen production and its vast potential as an energy carrier. We discuss how it transforms industries, revolutionizes mobility, and even helps us to reach our climate goals. But here's the thing. Gaseous hydrogen is taking up a lot of space. And if we want to truly harness its power, we need to make it denser. And that means compression. As you know, I'm an optimist, but can we really compress hydrogen efficiently, safely, and economically on the scale we need? Hello and welcome to our new episode of minus 253 degrees Celsius. It's the expert talk that gets to the point, in fact, to the boiling point of hydrogen. And today we're going to take a bit of a deep dive into the world of hydrogen compression. I'm delighted to welcome Marius Plingen from Bosch Rexroth. This is a company at the forefront of advanced system solutions for hydrogen compression. So Marius, thank you for joining us.
Thank you for having me.
I think we all know that hydrogen has a low volumetric energy density. My understanding is that compression is a key to actually overcoming this low density. Can you explain for all of our viewers in some simple terms why compressing hydrogen is so crucial for its widespread adoption?
The low volumetric energy density of hydrogen is a real challenge if you want to transport the energy that comes with the hydrogen molecule over a distance. And there are different ways of doing that. So we all might have heard of pipeline transport, we have heard of trailer transport. But in general, what you always have to consider is how do you make this transport as efficient as possible from an energy point of view. And of course, hydrogen taking up a lot of space and volume in the gaseous form just carries only a little bit of energy in that sense. And if you really want to make it in an efficient way, you have to really bring it into a small space and into small volume. You can either compress the molecules into a small space, then we talk about compression, so increasing the pressure, or you can also lower the temperatures, of course, but this is also energy intensive and also not that easy, but it's also possible. So wherever you want to transport hydrogen in your value chain, you have to consider one way or another to condition hydrogen, so increase pressure or lower the temperatures or both to make that possible and feasible. And just to give you a few numbers, so if you talk about 1 kilogram of hydrogen in the atmospheric condition, then it takes up of around 11,000 liters of volume, so really a large space. You can now think of typical compression stages, so for example, one is 350 bar or 700 bar. Then you already condense it down by a lot. So you talk about between 42 liters and 24 liters, for example, of space that is then needed, depending on the temperature also, of course. Or you can even liquefy it, and then you can condense it even down.
And before we get even deeper into the technology, I'm curious because I know Bosch Rexroth for its expertise in hydraulics and industrial drive technology. So how does this core competence translate into these cutting-edge solutions for hydrogen? And what are the specific technologies you're focusing on? And I'm also really curious how you deal with the peculiarities of hydrogen. You know, it's corrosive, for example. Yeah.
What is really important if you want to compress hydrogen, you need a large force, because to bring these molecules into a small space, you really need to apply large forces, and you need to do that in a compact way. And there, hydraulics is exactly that. So Bosch Rexroth is a market leader in industrial hydraulics and therefore has built different types of hydraulic drive systems for different applications, large varieties. So really the expertise and the know-how on building a very compact, a very efficient, energy efficient drive system that is also possible to service is very crucial to really be successful in building a very reliable and also sustainable compression system overall.
This all costs money, of course.
Yes.
And compression is part of the value chain for the whole chain of producing hydrogen for our end customers. Is it a significant cost in the whole value chain? And how are you working to optimize this efficiency and to reduce the costs?
Mm-hmm. It is a significant value, especially now if you talk about the scale of the overall infrastructure that we have today. So there are not thousands of systems, but there are a few hundreds built every year. And the first part is bringing down the investment costs in the beginning. The second part that is always very important is the cost during operation, lower the energy consumption, and also really make your system as reliable as possible, because as soon as your compression system breaks down, your whole value chain might stop exactly there. And that's, of course, already a loss of business for everyone that comes after the compression. So that's something you have to consider and also have a plan, for example, to have a service concept ready that can really bring your uptime high. And there, Bosch Rexroth is also a good partner in that sense, as we have a service organization that is operative all over the world. That's very important to consider.
That brings me to the idea of alternatives. And we've already mentioned a few moments ago liquefaction. What's the situation with liquefaction, maybe compared to the compression? What's the technology looking like there at the moment?
If we talk about liquid hydrogen and you also want to use hydrogen then still in the high pressure applications that we have talked about before, for example, truck refueling or car refueling or trailer filling, then you can use so-called cryopump technology. And the cryopump technology that is available today is based on basically the aerospace industry or even the LNG industry. But the challenges handling liquid hydrogen, compressing liquid hydrogen, they really come with really high requirements in terms of boil-off effect and blow-by effect. These kind of things you also have to consider, and also the requirements regarding material science that we've touched on before. They still apply, and now with liquid hydrogen at very cold temperatures, so minus 253 degrees Celsius is the boiling point, and even lower depending on what you want to do, or about higher pressure ranges. That's very, very challenging in a way. And Bosch Rexroth has taken a step forward here and really partnered up with a development partner and designed and engineered its own cryopump system, which is basically integrating two types of cryopumps into one station in a concealed compartment, all integrated and optimized regarding the KPIs that I've mentioned before. So efficiency in terms of serviceability, noise, and performance. Of course, we also have to talk about performance. There was still a gap in the infrastructure for high mass flow and high pressure applications, and there the Bosch Rexroth cryopump really comes into place. For example, delivering 600 kilograms per hour of up to roughly 900 bar, which is really state of the art.
What would you see as the next major breakthrough in hydrogen compression technology or in the liquefaction? And how do you think your work will help to achieve a really truly functional global hydrogen economy?
The next breakthroughs that are crucial is really to build reliable and efficient compression systems for the different applications that there are in the value chain of hydrogen. And there, of course, we would like to supply to the best of our know-how and competence our hydraulic drive systems to really drive these future-proof compression systems. And at the same time, talking about cryopumps or liquid hydrogen infrastructure, I think the next breakthrough could be that this technology will be accepted in the market as a future option, and therefore the developments will continue and the learnings will continue. But as you asked also for my contribution here, I think it's very important to bring together technology and people to really build future-proof, efficient and reliable projects and systems. And that's something where Bosch Rexroth really wants to be a reliable and trusted supplier for anyone that wants to work with us to build these compression and cryopump systems.
Thank you very much for this wonderful vision.
Thank you.
And thank you to our viewers on this minus 253 degrees expert talk. It's the expert talk that gets to the point, facts, the boiling point of hydrogen. And we'll see you in our next episode.